Here's just a couple of examples on how to find an average rate of change. So the first example is finding the rate of change from the graph of a function from a certain x value to a certain x value. So let's go ahead and note those x's first. So the first one, find the average rate of change from x equals -4. Well, that's right here, to x equals 2. That's right here. Because you're given a graph, yes, you can do calculations, but if you just remember that average rate of change is just a fancy way to denote a slope, then you could find the average rate of change from the graph just using the rise over run over slope formula. Let's go ahead and try that. Average rate of change for this specific function from x equals -4 to x equals 2. We're going to do the rise over run approach. So start with the first x equals -4. That's right here. Now count how many squares do you need to go up to get to this x. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 up. Up is a positive direction, so eventually it will translate to a plus on that 12. Now, how many squares do you have to the right to this next point? 1, 2, 3, 4, 5, 6. So 6 to the right. Both directions, up and right, are positive. If you had down, that would be negative. You'd have to add a negative sign. If you had left, it would be negative. You would have to add a negative sign. But for us, both directions are positive. So this is just 12 over 6, which is 2. So the average rate of change from x equals -4 to x equals 2 for this specific function is 2. Now let's try this from a table. So not a graph. We cannot use the rise over run. But again, remembering that the average rate of change is just the slope, you can use the slope formula. Part A says the height of the rocket from t time equals 0 to time equals 4.6 seconds. So this would be your t1, and 4.6, this would be your t2, which means that this is h1 and this is h2. Usually we do y's and x's, but you can translate that. So y2 minus y1 over x2 minus x1 with our letters. It would be h2 minus h1 divided by t2 minus t1. h2 is 138, h1 is 0, t2 is 4.6, t1 is 0. So this is just 138 divided by 4.6, which is 30. And since it is a slope or the rate of change, the units would be meters per second. Part B also asks for the average rate of change, but we're not starting at a 0 at this time. So T1 would be 2.3, which means that H1 for the second part would be 92. And T2 would be 9.2, which means that H2 for part B is 23. It's the same formula, M equals, I'm not going to do Y's this time, so this is H2 minus H1 divided by T2 minus T1. H2 was 23, H1 was 92, and T2 was 9.2, and T1 was 2.3. So this is the same as -69 divided by 6.9, which is -10 meters per second. So what does the negative slope means in this example? Well, since the slope measures this essentially the velocity of the rocket, and the positive velocity means that the rocket is accelerating. The negative velocity means that the rocket is decelerating. The speed is becoming less with time.